we're going to take a look at state symbols and see how we can predict which state a substance will be in at a particular temperature. When we write chemical equations, we sometimes need to show which state each substance is in, and to do this we use state symbols. So for solids we put an S, for liquids we put an L, and for gases we put a G. Sometimes though, you'll have a substance that isn't in one of these pure states, and instead is dissolved in water, which we call aqueous. So for this, we put AQ. For example, if we put some sodium in water, it would form sodium hydroxide and hydrogen. As sodium is a metal, it would be solid at room temperature, which would show by writing an S in brackets after the Na. And then we'd put an L after the H2O, to show that it's a liquid. The sodium hydroxide is a bit more difficult. It's basically an ionic compound that's dissolved in the water. So it's no longer a solid, but it's also not a pure liquid. So instead we call it aqueous and write AQ. Then finally the hydrogen will be given off as a gas, which we show with a G. In your exams, you might be asked to predict which state a substance would be in at a certain temperature. For these, they'll normally give you some data, like in this table, and then ask you questions based on that information. For example, what state are water, copper, and magnesium in at 800 degrees Celsius? One way to conceptualize this stuff is to imagine the temperatures on a number line. So for water, we can see that its melting point is 0 degrees, and the boiling point is 100 degrees. So anything below 0 degrees, and the water will be solid ice, because it hasn't melted yet. Then at 0 degrees, it melts into a liquid, and it will stay liquid for all temperatures up to 100 degrees, at which point it boils and becomes gaseous water vapor, and stays a gas as we increase the temperature further. So at 800 degrees, water would definitely be a gas. Then for copper, we can see that it doesn't melt until 1083 degrees. So at 800 degrees, it must still be a solid. And finally, magnesium has a melting point of 650 degrees and a boiling point of 1107 degrees. So it'll be between the two, and so a liquid.